short talk about integration of raster time series with the sensor web. So these are actually the results of a research project that is called MUDAK-WRM, MUDAK for multidisciplinary data acquisition for water resource management. So what we actually did in the project, the motivation is that there are numerous models for hydrological ecosystems, but for most of the models, there's a low data availability. So most of the models must be run with either default data or no data. So we want to actually enhance the adoption of those models, and therefore we had made a trade-off among less key parameters and reliability, but we wanted to use key parameters mainly from remote satellite sensing that allow us for a certain stage of reliability for these models. So what you see at the left side of this image is that we take remote sensing data as well as in-situ sensing data, and put it somehow manage it in a data pool, and also the modeling data that is made upon these data. And at the end, we of course want to have visualization of those. So what we were able to do before was that, especially for in-situ sensing data, we can visualize, for example, with the sensor web client, the simple data. So simple data in that case, that we have a timestamp and a value. So mostly those values that are that come from automatic sensing devices. And we also wanted to visualize and integrate remote sensing data, and also those in-situ sensing data that comes, for example, from profile management or trajectory measurements. The project data workflow is actually very, very easy. So what we do, we collect the data on an old school FTP server, but with a well-defined folder structure and a well-defined file format for both in-situ data and remote sensing data. That was due to the size and due to the organization of the whole project. What we do then is data synchronization of the remote sensing data with the WMST and WCS interface of the geo server. And for the in-situ data, we do data synchronization with the sensor web server, especially with the Helgoland API, which is able to provide profile and trajectory measurements, and then visualize it in a client. So for the next thing, I want to go into a MUDAK client. So on the right hand side, on the right bottom there, it's the important part which I want to present. What we have here is a bounding rectangle of the satellite image, in this case chlorophyll. And what we actually did, and we defined some points of interest, and through the time dimension, we visualized it on a graph. This is for a certain boundary rectangle, and as well for some kind of data explorer. What we wanted to do is to integrate all the data, no matter whether it's in-situ data or profile data. So we actually visualized all data on the map with some where we can select the data actually, and it is visualized on a map and also visualized in a list down here with a small preview screen here of what the data looks like. And this is computed actually on the fly what kind of visualization technique we want to use either this classical time series or some kind of isoplate visualization. We have our parameters here. If I go again to chlorophyll, then all the chlorophyll data is shown here. And then I can also see the previous year, integrating it with the remote sensing data. If I choose the chlorophyll here, then the image or satellite data is integrated to the list here. And now I'm able to make a time dimensional request in clicking on some part of the screen here. And now in the background, it requests the values and shows me in this case the chlorophyll data of this point in the reservoir. So yeah, that was actually it. And thanks for the attention.